Today we're going to continue our discussion of solving systems by elimination. As we know, a system is basically two functions or two lines and determining where their solution or intersection point. A common x value or input value for every common y value that works on both equations. And there's always one point, or possibly no points, that produces that. Previously, what we've learned is that we can use elimination to easily solve a system of equations. Now for this set of functions, negative 10x plus 5y equals 25 and 10x minus 2y equals negative 16, we can either eliminate the x terms or the y terms. Which would you eliminate? Well, we would want to eliminate the x terms because we have negative 10x plus 10x is going to allow us to cancel those and make those 0. Remember, before you answer, the result should be 0. Right? The result should be 0 of everything that you add or subtract together. And in this case, the x terms easily do that. The y terms, of course, won't. So to eliminate the x terms, we would either need to add or subtract the terms. Which should we do in this case? Yes, in this case, we're going to add the terms together. And once we do that, that eliminates the negative 10x and the positive 10x. Now we continue our elimination by 5y, and then plus a negative 2y is going to give us 3y. And then we go ahead and 25 minus 16 gives us 9. And we end up with 3y equals 9 once we've added these two sets of terms together. So once we use elimination, what's our next step? Well, once we're down to one variable, it's very easy to go ahead and solve for that variable and get a numerical answer. In this case, y is going to equal 3 once we divide both sides by 3. So once we know one variable, how do we find the other one? Right, you're going to substitute that y equals 3 back into one of these two equations. So you're going to take that y equals 3 and put that back in for y, and you can pick one equation. You can either pick this one or this one. One of these two equations we can pick. Just for simplicity's sake, and again, they both work, I'm going to go ahead and choose this one, 10x minus 2y equals negative 16. There's no particular reason why. It's going to work fine for both. So what we're going to do is I'm going to take that equation and I'm going to substitute the y equals 3 into it. So we can see that instead of y, I now have a 3, and then I can go ahead and evaluate like I normally would. Negative 2 times 3 is 6. And then we'll add kick over the 6 to both sides, and that eliminates the left side and allows us to add these together, negative 16 plus 6, and that's going to give us negative 10. So we have 10x equals negative 10. You can probably do the rest in your head, but if you don't, you divide both sides by 10, and that's going to give you x equals negative 1, because negative 10 divided by positive 10 is negative 1. You may also use the calculator to find that input value if you find matching y values on either side. So the calculator strategy also works here. Once you have both solutions, a value for x and a value for y that work for both equations, we can go ahead and reorder those into an ordered pair, and that's our solution. Negative 1, 3, negative 1 being our x value and y being our 3 value. And again, you substitute these both into both equations, and they should work and be a true solution. The only true solution, the single point where both lines are graphed, and that's the point where they're going to intersect. However, let's take another example. Could we use elimination to solve the following system of equations? At first glance, we can't eliminate the x terms or the y terms. If we try to eliminate the x terms, negative 10 plus 20 is going to give us positive 10x, so that doesn't work, right? Or we could try to eliminate these two. 9y plus 3y is going to give us a total of 12y. So unfortunately, that's not going to work either. So what could we do to use elimination? If we multiply one of the equations by an integer, either the top one or the bottom one, we could find a way to match them up and eliminate one set of terms. That gives us several options to eliminate either the x terms or the y terms. So let's start with the x terms. Let's eliminate the x term by multiplication. We're going to take the top equation here, and we're going to do some elimination here. Our first step is to multiply both sides by 2. I'll explain why in just a minute. So what I would do is I would multiply this side by 2 and multiply this side by 2, and then go ahead and produce this. Now, why did I pick 2 to multiply? Because I knew this was a positive 20 right down here, This was a positive 20, and this was a negative 10. If I multiplied this by 2, I would get negative 20. And now notice these two have a match now, right? And then, of course, everything else has to be multiplied. So 2 times 9 is 18, and then 2 times 17 is going to be 34, and that gives us basically another equation to use. Now, and again, this top equation is still equivalent. So now we could eliminate the x term and basically get the 0x that we are looking for. All right? But that's not the only way to do it. We can also multiply both sides by negative 3 if we want to eliminate the y terms in the multiplication. So we tried doing the x terms, we can also do the y. If we multiplied both sides by negative 3, watch what happens here. Negative 3 times 20x is whatever that is, and negative 3 times positive 3, what's that going to give us, and how does that relate to this positive 9y, I mean? We're going to get negative 9y once we do the distribution. Negative 3 times 20 is negative 60, negative 3 times positive 3 is negative 9, and then negative 3 times 29 is negative 87. So we can distribute that, and of course that gives us two equations, and now we can eliminate the y term because we have a positive 9 and then a negative 9. So we add those together, and that would give us the 0y that we're looking for. What's great about these methods is there are options. There are usually several ways to solve by elimination if you start multiplying out the top or the bottom terms. So can we use elimination to solve the following system of equations? We have an x minus y equals negative 2. Which set of terms would you eliminate, and what would you multiply by in the top? And we'll use the top equation. So what would you multiply the top equation by to eliminate the x terms? What would you multiply the equation by to eliminate the y terms, if that's what you choose to do? Well, let's quickly do both side by side. Okay, if we eliminate the x terms, obviously we're looking for a negative 5x, so we want a positive 5x here. If we eliminate the y terms, we're looking at a positive 8y, so we want a negative 8y here. So that tells us in both situations we want to multiply the left side by 5, because that's going to give us the positive 5x we're looking for here to eliminate this. Here we want the 8 times negative 1y, so that's going to give us a negative 8y and a positive 8y, so we could eliminate that. So that gives us, again, it gives us options. So if we were to do that, we get 5 times x is 5x, 5 times negative y is negative 5, and then of course you eliminate from there. Once we do that, on the x side, the 5's eliminate, on the y side, the 8's eliminate, giving us basically a simpler equation that we can use to solve for x or solve for y, and basically the rest works like normal elimination. So what is important is that you have choices. Okay? Of course, some eliminations may work better than others, and it's up to you to figure out which ones work for what situation. So let's solve this system. Remember, choose which set of terms to eliminate, either the x or the y values. Then multiply a value to one equation to get a matching set of terms that you can successfully eliminate. And then add or subtract the equations as you normally would for elimination, and you should find a solution for one of the two variables, and then you can substitute in and solve from there. So that's basically substitution via elimination by manipulating the equations through multiplication. Okay, so do this problem, and good luck.